So before starting the demonstration, let's familiarize ourselves with the software interface. So this is how the software interface of PV emulator looks. We can divide this software interface into four sections. In the center, we have the graphs. The blue curve indicates graph between current and voltage, and the red curve indicates graph between power and voltage. In the left side, we have irradiation as inputs, and we can change these as per our requirement. We also have area, so we can change the area of the panel using this section. This is the communication interface. So we can change the whatever COM port our PV emulator is connected with, and we can switch on the PV emulator using this on off button. In the bottom section, we have user defined parameters where we can change the values of VOC, ISC, temperature coefficient, VG, diode quality factor, series resistance, and operating temperature for the PV emulator. In the right section, we have calculated parameters and measured parameters. So these calculated parameters indicate the calculated values based on user-defined inputs. And these measured values indicate the actual output values which we are getting from the PV emulator setup. So to run the software, we just simply have to click here at the run button and it will start working. Because we have not connected the hardware setup right now with the software, that's why we are getting this white indication. Otherwise, it would have been green, indicating that the connection is successful. So we can, let's say, we can put on the values of VOC as 50, we can put the value of ISC as 5. We can leave the rest settings as it is, or if you want to change, you can change the settings. To see the graph properly, let's increase the scale of the graph. I'm setting this to 60, and I think we don't need to set the current. So right now we can see the P versus V curve and I versus V curve for the PV panel of our choosing, and we can change these values. We can change these values as per our liking, as per our requirement. And here we are getting the calculated parameters based on what we have defined here. So for 47 VOC, 5 ISC, 0.001 temperature coefficient, 1.12 VG, and 1.2 diode quality factor, and 0 series resistance at operating temperature of 298 Kelvin, we are getting IMPP at 4.86 ampere, VM as 42.91 volts, power as 208.5 watt, fill factor as 88.73, and efficiency as 57.92. So this efficiency is looking so high because we have not defined the area properly. So let's increase the area and you can see the efficiency going down, right? To change the irradiation, we can change irradiations from here. So we can get up to up to 4 peaks for the partial shading, and we can also increase the scale of these irradiation values as well. Right now, in measured parameters, we are not getting anything because the actual hardware is not connected. So when we connect the actual hardware, we'll get the actual voltage, actual current, and actual power consumed by the PV panel or by the PV emulator. So we can change all these values while the system is running. There's no problem with it. And we can change the irradiation, we can change everything while the system is running. To switch on the PV emulator, we have to just switch on this button and it will indicate the PV emulator is switched on. Right now, PV emulator is not connected. That's why here we are getting the white indicator. And that's all about the software. Thanks for watching. Do subscribe for such videos. And if you have any sales inquiry, you can follow us on these social media channels or write to us at the given email ID.